improper fraction, how does the numerator compare to the denominator? Yes, Trinity, go ahead. The numerator is always greater than the denominator. Okay? If it's equal, it'd be the whole number. That's actually word for word from the textbook. So I think the person that said greater than or equal to, I would accept that as a correct response also. So can I get somebody to respond to number 2? What's the answer to number 2? Nathan, go ahead. 13/5, very good. And does everybody here remember how to find an improper fraction from a mixed number? Is there anybody who has a question about that? So everybody's good on that skill? Okay. So can I get somebody to answer number 3? Number 3. Taylor, go ahead. 13 over 2. And then who's got number 4? Olu, go ahead.
5/3.
5/3. And then who's got number 5? Talise. 19/4. Very good. Any questions about the warm-up? Okay. All right. So here's what we're working on for today. Not much to today's lesson. It's pretty easy, but again, if you don't practice something that's easy, something easy actually is hard because you don't remember what it was about. So tonight, make sure you do the homework. What you'll learn: to multiply fractions in mixed numbers and to solve problems by multiplying. Why learn this? You multiply fractions to find part of a quantity, which is useful when you cook. A baker makes a batch of bread dough and splits it into 3 parts. Then she takes half of 1 part for 1 loaf. You can multiply 1/3 times 1/2 to find the fraction of the batch she uses for 1 loaf of bread. When multiplying fractions, you do not need to find a common denominator. You do not need a common denominator. You multiply the numerators and multiply the denominators. So let's take a look at the key concept box. So multiplying fractions. So here's the example that's mentioned above. If you are multiplying 1/3 times 1/2, that's actually the easiest operation to perform on fractions. To me, the most difficult ones are addition and subtraction, because you can't go straight to adding and subtracting until you do what? You have to have a common denominator. So there's an extra step sometimes, right? And then for multiplication, most of the time you can go straight into multiplying. And it's pretty easy, because if you look, to find the numerator of your product, you just multiply the numerators. So 1 times 1, that's my new numerator. That's my answer. Got it? And then to find my denominator, you multiply the denominators. So 3 times 2, that's my denominator, 6. So the answer, the product, is 1/6. Do you see how easy this is? It's the easiest one to do. The next easiest one is division. And there's just one extra step on top of what you do for multiplication. We're going to cover that this week too. So if you look at the algebra, I do want to bring this up to you. Some of you guys that are interested, college-bound, a lot of students, basically any student that's going to college, you're going to have a calculus. You're going to need that. Yeah. And a concept in calculus is undefined. It's going to come up again. And undefined occurs when you have a situation where you're dividing by 0 or you have a fraction with 0 in the denominator. And that's what they're saying here, that you can't have this. You can't have 2 fractions that are multiplied if one or both of the fractions have a denominator that's equal to 0. They're saying it can't be 0. Do you guys, I'm just explaining this to you in regular terms. Okay? So I should never have a fraction where there's a 0 in the bottom. Okay? That's called undefined. And you'll see that again later. Okay? So it's not terribly important now, but just understand that my denominator should never be 0. Okay? Now, I've shown you an example, and I've walked you through an example. Now it's your job to try. This is where you guys try. This is where it's okay to make a mistake. Now, I see hands that just went straight up, and I covered it, and I know you didn't even write the problem out. Write the problem out, work it out. Not yet. Write that out, work it out. Okay. Questions I'll save for somebody who wants to share the answer with me. And then if we have a question after that, we'll talk about it. So who wants to explain this problem? Tori, go ahead. Okay, so you're going to multiply 5 times 2, and what part of the fractions are those?
That's numerator.
Those are the numerators. So we're going to multiply my numerators, right? And so that's the first step, multiply my numerators. Then what's the next step?
Then answer number 10, then you want to multiply the denominator.
Right, so we're going to multiply the numerators, and then we're going to multiply the denominators. What's the denominator going to be when I multiply it? 24. So here's my fraction. Are we done?
No.
No. On a multiple choice test or quiz, that will be one of your answers. Don't get fooled into choosing that as the answer. Just because you see something from your work, don't get excited and say, oh, there it is, and circle it, okay? Because a lot of you are doing that. It needs to be in simplest form. I can't tell you how many tests I graded where you were literally one step away from getting the right answer, okay? I'm saying this now because I don't want you to make that mistake. So what is this in simplest form? I need to find the GCF. Lola, what's it going to be?
It's going to be 5/6.
I divide the numerator and the denominator by the GCF. In this case, is 2. It's going to be 5/12. If I divide 10 by 2, I got to divide 24 by 2. Okay? I got to use the same factor that I divide the top and the bottom by. Okay? That's okay. A number of students were making the same mistake, so I just want to clarify that. Whatever I divide the numerator by, in this case, if I divide it by 2, I also have to divide the denominator by 2. Okay? Is there a question in the back? Kalila.
Webby's bathroom. I think she needs to go because she can't see.
Right here. Here's what I want you to do now, and I'm going to give 3 people to do these problems. Quinn, you got the first one. Unisa, you got the second one. And then Dominic, I'm going to give you the last one. Shh. If I didn't give you a problem, that doesn't mean you don't try to do the problems. I had somebody ask me earlier.
I did. You don't even have the sheet. We don't have the little booklet thingy. I have before. Ladies first. I asked before her. I thought you said no.
Because I have her doing something for me on top of going to the restroom. So how about you worry about you for now?
Bless you.
Okay, who had the first problem? Quinn, walk me through this.
So the first step is to multiply the numerator.
Right, and so when you multiply the numerators, what did you get?
I got 3.
Good. And then what's the next step?
To multiply the denominator.
Right, so the second step is to multiply the denominators. And what did you get when you multiply the denominators?
Got 20.
Okay, so your fraction as your product was what?
Was 3/20.
Okay, and did you need to simplify that? No. So Quinn's correct. The answer is 3/20. Are we good? Okay, who's got the middle one? Who did I give the middle problem to? Unisa, are you ready? Okay, go ahead and walk me through it, Unisa.
For the first step, you multiply the numerators.
Okay, and what did you get for the numerator?
20.
Okay, and then what's the next step?
Multiply the denominators.
Then what'd you get?
30.
Okay, so your fraction, what do you have for your fraction now as your product?
20, 30.
Right, and is that your final answer? No, what's your final answer?
4/6.
And 4/6 is close. We can take it a step further. Doesn't 4 and 4/6 both have a common factor? What? Okay, so what's it going to be simplified all the way? 2/3. Some of you are being very rude. If I didn't call on you, please remain quiet. Good job, Anissa. Now, again, a lot of you are simplifying, but you're not getting it in simplest form, okay? You're a step away from getting full credit for the problem. So you need to make sure you're always asking yourself, is there any other factors that can go into the numerator denominator? Got it? Now I gave you a method. If you find the GCF, it'll give you one step all the way to the simplest form. But some of you guys aren't doing that. Whatever method will work for you, fine. But some of you guys are struggling with that. Who's got the last one? Dominic, what's the last problem?
Okay, so first you multiply 2 by 4, which is 8.
Right?
And then multiply 3 by 5, which is 15.
Okay, so what's my fraction going to be?
8/15.
And can I simplify that any further? Okay. Does everybody understand how we got these problems?
Yeah.
Okay, here's what I need you to do now. You're not always going to be dealing with a fraction. You might have a fraction and something else. Well, the first something else you might encounter is a whole number. But if you guys remember, early in the year I said, hey, you need to know this trick. You need to know how to turn a whole number or an integer into a fraction. How do we always turn any integer into a fraction? Adipoju, thanks for raising your hand. What do I do?
So you put the integer whole number over 1.
Okay, so whatever the integer is, I put that in the numerator, and I put in the denominator 1. That's how you make it into a fraction. So now, if you remember us going over that, that is what you're going to do to solve this problem here, the example. It says, on Friday, 3/7 of 28 students in class went to a music competition. How many students were still in class? So you need to figure out how many students are still in class. Make sure you label your answer too. So I gave you the pieces. I need you guys to put the pieces together and solve this question. Did you get the right one? I'm going to give that back and get the correct one. Do I have a volunteer to explain this question? Joshua? Thank you, Joshua. Hold on a second.
Let's make 28 a fraction, which would be 28 over 1.
Okay, Joshua, correct. We're going to make 28 into a fraction, so we're going to make 28 over 1, 28 ones, or that, I guess that's how you would call that fraction. And then what?
And then you have to multiply that by 3/7.
Very good. So we're going to multiply that by the fraction 3/7. Now I'd like to bring something up because somebody in the earlier class asked this, and I think it's it's important that we talk about this. Do I need to have this 28 first in front? Does it matter the order?
No.
Why not? What property allows us to change the order? It's Kayla. Very good. Commutative property. Commutative property of multiplication says that, hey, I could change the order of my numbers, and I still get the same thing back. Okay? So, continue to walk me through this, Joshua.
So 28 times 3 equals 84, and 7 times 1 is 7. So it would be 84 over 7. When you simplify it, it would be 12.
So 28 times 3 was what?
84.
84. And 7 times 1 was 7. And that's simplified to what?
12.
12. But we need to make sure that we label our answers, right? So 12 what?
So 12 students.
12 students, correct. Okay, so we just worked one out. Now I need you guys to go ahead and solve this problem.
There's another method for
Yes, there are other methods, and I'm not going to go into too many of the other methods. If you guys know how to cross cancel, great. I don't want to get into that because that's going to throw some people off that are just trying to get this down, okay? So if you have another method that helps you cancel before you actually do the product, fine. As long as you get to the correct answer, I'm okay with that, okay?
I did it differently. I'm confused. I'm just to make sure I got the right answer. I did 3/7, and then I multiplied both numerator and denominator by 8 instead to get 28 for the numerator.
I'm not sure I follow what you did.
Like,
If you multiply but the numerator and the denominator by 8, you're multiplying by 1 basically, and it's not going to get you in the right direction. Okay, there is a way we could have canceled things out. And those would have gone away, right? And then 4 times 3 gave me 12. 1 times 1 gave me 12 over 1, so 12 students. Okay, that's the cross cancel. Is that the way you guys were talking about? Okay, if you know how to do that, great. If you don't, I'm just trying to show you how to get there. It might not be the most efficient way, but I just want to get everybody a strategy. Okay? Yes? You have the next answer?
Yeah.
Okay. Go ahead, Taylor.
Okay, so instead of 168, we're going to do 168 over 1.
Okay, we're going to rewrite 168 over 1. So we made that into a fraction, and then what are we doing?
And then we're multiplying that by 3/8.
Okay, very good. We're going to multiply that by 3/8. And then what do we get for our product?
Our numerator is 504.
504.
And our denominator is still 8.
Our denominator is 8. And that's going to simplify. What's that going to be?
504 divided by 8 is 63.
Correct. So we have 63. And we need to label this.
63 members for the batch.
Right. Or we could even be more precise than that. We could say 63 violinists. Okay? Did I spell it right?
Yes. I think so.
Okay, yeah. All right, moving along. Here's the next thing. Now, I want to talk to you guys about what we did for the warm-up. Now, this is as challenging as it's going to get. The reason why we had the warm-up is so that we can see all the pieces that we need to solve this problem right here. So I don't want to tell you exactly. I already kind of told you what to do. You have the pieces to solve this. And then whoever is willing to volunteer the answer and explain to the class the answer, that would be wonderful. But I want to give everybody a little bit of a chance to try and work this out. Oh, what's your question?
For like the past problems that we've been doing, when you're multiplying the numbers by each other, you just put like the one multiplication sign and then you just put the fractions there. When I'm doing it on my homework, you say that that's wrong.
Oh, no, because I circled it and put an exclamation on some of the homework. Yeah, I'll talk to you about that in a little bit. And we're gonna see why it does relate to this. Yes, so your question, I'm going to talk about that. It actually relates more to the last problem where we had the whole number, right? Because think about what you did in the homework. You said times 2. Well, you're really only multiplying by 2 over 1, not the numerator and the denominator. Do you understand now why I said what I said? That's why. Talise, can you walk me through this?
So I turned both of the mixed numbers
Uh-huh.
into improper.
Okay, so what's your first improper fraction going to be?
13 over
13 over what?
5.
Nice. What's your second improper fraction going to be? 9 over 2. So here's what we got to start out with. Okay, are we good?
Yeah.
Okay. So you had to first take your mixed number and make them into improper fractions. That's the first step. Yes, you can't just multiply the whole numbers or you can't multiply the pieces. You have to take it and convert it into an improper fraction. Got it?
Wait, question.
Yeah.
Like on a test or a quiz, if we do it a certain, like different way and still get the same answer, would that still be wrong?
There's more than one method for a number of math problems, okay? Sometimes, what I've noticed with students is sometimes they might have a method and it only works in special situations, and then they're wrong in other situations. So this method is going to get you the correct answer every single time, okay? All right. Continue. What's next?
So then we multiply and 13 times 9 is 117.
Uh-huh.
And 5 times 2 equals 10.
Okay. Are we done?
No.
What's my final answer? Or maybe my final answer.
11 and 7
So we did the division. We saw we had a remainder of 7. 11 wholes and 7 parts of 10. Did you guys get that? Okay. So first step, if you don't have fractions, you got to make them into fractions. Okay? Once you make them into from mixed numbers to improper fractions, then you can go ahead and multiply them like you normally do. But in the end, you got to rewrite it back. If it's an improper fraction, you got to convert it back. Okay? Now, if you understood those problems, now what I need you to do is see if you can do these 3 problems. And I'm going to pick 3 people that I haven't called upon yet. Joshua, can I get you to do one? Nathan, I don't think I've called on you yet. Kayla, I don't think I've heard from you yet. Yeah. Somebody's out right now. When he gets back, you can head out. You ready? Yep. So everybody should be making sure they got this locked down. Try all 3 problems, even if I didn't assign a problem to you. Nicholas, you ready? Oh, I meant Nicholas, sorry. Come on, let's try it at least. Nicholas, what's the first step?
You have to convert 2 1/3 and 4 5/8 into improper.
Okay, let's go ahead and do that.
That would be 7 over 3
Uh-huh, and we're going to multiply that by what? Keep going.
times 30. Oh wait,
No, you're right.
32 over.
Hold on.
37 over.
Mm-hmm. Okay, now, what's that going to be? Do the easy one first. What's the denominator?
24.
Okay, can you work out the top, the numerator? Do you know it? Please don't call out if it's not your turn. I need everybody facing this direction. So I need to multiply the two numerators to get my new numerator. Seven times 7 is what? 49, right? Carry the 4. And then 7 times 3 is what? 21 plus the... Okay. There's a lot of people talking over Nicholas. I need you to, first of all, stop being rude. You know what the procedure is in the class. If I call on you, then I want to just hear from you. I don't want you talking over whoever I'm called upon to work out a problem. So Nicholas, you're close. Go ahead and finish it up. So 7 times 7 we saw was 49, right? Carried the 4. 7 times 3. 21 plus the 4 that we carried, right? Okay, what is the final fraction going to be? Please stop.
10 and 9.
Not 9. It's going to be, leftover is going to be 19. Right? Because 240 from 259. Are we good? Okay, who had the middle one? Nathan, go ahead. Okay, what's the first?
3 and 3 fifths becomes 18 fifths.
Mm-hmm.
And 1 and 3 tenths becomes 13 tenths.
Okay.
And then I multiplied 18 times 13.
Right.
And got 234.
Okay, good.
And then I multiplied 5 times 10 and got 50.
Okay.
And then I know that there are 4 50s in
Nice.
34, so 4 is my whole number.
Mm-hmm.
And then my fraction, I got 34 50ths, but then I simplified.
Okay.
I got 17 25ths.
Nice. Perfect. And then the last problem. Who did I have that? Kayla? Go ahead.
So first you change the mixed numbers into improper fractions.
Uh-huh.
So the denominator will stay the same. So you multiply the whole number by the denominator, which is 20.
Mm-hmm.
Add the numerator, so it's 23 over 4.
Very good. 23 fourths is what we have, and we're going to multiply by what?
Then you do the same thing. So
Mhm.
it's 16, and if you add the 5, so it's 21 over 8.
Okay, very good. Okay, and then what do we get when we find the product of these?
483 over 32.
Very good. 483 over 32. And then when you simplify that, what do we get back?
15 and 3 30 over 32.
15 and 3 30 seconds. Okay, very good. Almost done. Home stretch. Class, what goes in these boxes to complete this statement so it's true? Top box, what's that going to be?
3.
Bottom box. 4. Good job. Okay, what goes in this box here in the middle one? 1. Very good, because we have 18 here. That means this has to be 18 over 1. Okay? This one didn't change. Okay, what goes in my numerator for this first fraction? 9. I heard 9. I didn't hear many people say 9. Now, those are just shouting out. They didn't really know. They just waited for the people that knew the answer to call it out. Work out the second box. What's it going to be? There we go. 5. I feel better. Now, right here, you guys can look at the answer for reasoning in a number sense. What I really wanted to discuss with you was the product model here. And so let me just explain to you what's happening. So we have this first box, and watch what I'm going to say for this first box. So here we go, in green, and I'm going to have that match. Oops. Okay, so here, hold on a second. Knock it off. A day. Come on up. Sign out. Okay, so this box right here, look at the area, look at the boxes it fills. How many what fraction of the whole am I filling up here? Do you see in green, the green box?
24, so that's
I heard it. Who said it? 5, 6? So I have 5 rows here out of 6 total. So here it is, 5, 6. Okay? And we're going to take that fraction and we're going to multiply by this other shaded area, the shaded area that's in pink. And how much of this, what fraction of the whole do we have here? We have 1/4. So this is 1/4. And then if you notice, the two shaded areas overlap to form this purple shaded area. How much is that? How many rectangles do you see here? I see 5 out of how many rectangles altogether? 24. So I have 5 24ths. Now take a look at the model. If I take the shaded area that represented 5, 6, and I multiplied by the other shaded area, 1/4, I get the overlap, which is 5 24ths. 5 times 1, 5. 6 times 4, 24. Do you guys understand? Yeah. And really quickly, just for the sake of the video, who said no? Okay, what's your question?
I don't get the answer because I don't feel like it overlaps it, but I don't know how to make that answer.
Right, well, do you see in the box here, I have 1, 2, 3, 4, 5. Okay, but all together, I have, how many do I have in this first column?
5 and 6.
I have 6, and then how many? I have 6 in this column, but how many columns do I have? 4, right? So 6 times 4 is what? 24. So I have 5 out of 24 altogether. So that's that fraction where they overlap. Do you understand? But if we multiply the blue shaded area that has the overlap also, that was 5, 6. And then the pink shaded area that included part of the overlap, 1/4. If we multiply these out, we get that fraction back. So I'm just going to go ahead and read to you. When you multiply two fractions, do you need to find a common denominator first? No. Now, in order to multiply, sometimes you can't just start multiplying. What are the special cases where you have to fix it? Can somebody tell me the first one we saw today? Jayla. So if there's a whole number, what do we do to fix it? I make it into a fraction by putting it in the numerator and a 1 in the denominator. Now, if I have the second situation I have to fix, we saw, what do I have to do? Adipoju.
you have to convert the mixed numbers.
So if I have mixed numbers, I have to convert them to what? Improper fractions. Okay, and then the last example, number sense, is 5/7 of 28 more or less than 28? Well, 5/7 is part of a whole, right?
Correct.
Now, what would the fraction have to be so that it would be equal to 28? 7 sevenths, perfect. Got it? So 7 sevenths would be equal. 5 sevenths of 28 would be less. Can somebody give me what would give me more than 28s?
Oh my God.
Nice. Any mixed number. So you gave me one 28 and 5 sevenths. But any mixed number would have given me more than 28, right? So it's just conceptually, if we have a fraction of something, it's going to be less than 1. If we have something that's equal, the fraction will be 1. If we have something that's more, the fraction will have to be greater than 1. Do you understand?
Yeah.
Okay. Now,